8 of you. Go, please. You all should have picked up when you came in the next note packet for this unit. You're going to, when you get home tonight, so you're aware, your homework is, instead of giving you a side packet for that, I just posted what it was through Google Classroom. You'll see that there's actually 3 documents there. One is the blank note packet if you ever need a second one. One is the homework packet. The questions are substantially bigger than they were on the miniature ones that I gave you the other day. And and one day for homework, there's a worksheet, and that worksheet is there too. But I'll have you go through and I'll print out a supplemental copy for it of that individual worksheet for that day. So if you haven't already, make sure please that you go and sign into the calculator. We'll save this again. It was a little bit, well, hopefully I'll have your exams graded and input into the computer by the end of the week. You guys are a little bit behind the ball just because the 4 sections of Enriched and AP Calculus have all had exams on or around the same day. So I have 137 kids' papers to grade, and they're all 4 pages apiece. So getting through a little bit over 600 pages of grading is not as much fun as it sounds. So hopefully the stuff that we go through and do, and hopefully I'll have those for you by the end of the day, or sorry, end of the week. Don't invest too much in stressing out over what you get on the test. I know some of you are number worshipers. The thing that we have to get through our head is, we talked last time about that disconnect from Geo to your Regents score and just what's causing it. It's actually frustrated me even more than normal. But so you know, did I show you this last class or not? Okay, so this was mapping of the kids before. This right here is their, this right here is their 4-quarter average for the last grouping of enriched kids. And there were 50 on the button, yeah, 50 students last time, okay? This was their average for the 4 quarters, and this was their Regents rate. Now, the reason that I show you this is to show you not only, obviously, I know what I'm doing by leaps and bounds, but so you know what to go through and expect for yourself. Out of this group, in this column here, represents the difference between the 2 of them. So, this person's average was a 77, their Regent score was an 84, which means they went up 5-7. Now, I can't fathom, you all almost universally were on the other end of that spectrum, meaning your difference would be negative. Now, out of 55 kids, we are at, and by the way, the most outrageous of them was a couple of 6s and 7s out of 50 kids. I think that there's, 5 of them? So 10% of the group scored more than 5 points above, which means their grade during the quarters was actually suppressed as opposed to inflated. But in any case, the thing I need you to see is, look at how many kids scored above, at or above what their 4-quarter average is. 38 out of 50. What percentage is that? Okay. 76% of the kids scored at their average for the 4 quarters or above. That's exactly, and then look at how far off I was on the kids that weren't. I had 1, 2, how big is that? 1, 2, 3, 4, 5, 6, 7, 8 kids, it was my fault, were 2 points below. And then there were 4 of them where I would say that is my fault. They were 4 points or more. The highest, by the way, was 9 points. And here, didn't we have a bunch of you that were more than 10 points difference between your scores? Yeah, that's completely unacceptable. Completely unacceptable. But for us, it seems like coming in, it's the norm. I'm not going to go through and give you another pep talk because, frankly, you should still be so motivated from the last one. But you all are exactly where you need to be. we'll say it this way. Would you rather it be, raise your hand if this, if you'd rather you have the region score within a point or two of your 4 quarters? Who would like that? Who wants that as well? Okay. Who wants your 4 quarter grade to be super high and then have a 70 on the regions? Who would be okay even if your 4 quarters was like an 85? Let's say. What do we got? Who would be okay with having, here's a good one, middle of the road, 83 for an average and 88 on the exam? Who would take that? In all honesty, that's legitimately good. Because looking at how you all did on the Geo Reg, it was not, for me personally, that was terrible. Even looking at what the Regents exam to the Souths were, so, oh, this was small, it's larger, small. Okay. In terms of what we have, this right now is 35 kids out of 50, which is 70% scored an 85 or above. And I think that's low. If you go through in order next year to take pre-calculus as a dual credit course, you need to get an 83 or above, and 41 out of 50, which is 82% of the kids were able to go through and do that. That to me was way too low. The floor on your grades should be an 83 for everyone. And that means I personally missed 9 kids, 8 kids that couldn't take it for a dual credit class. That's 4 college credits next year as a junior. The goal for you is all of you are going to be taking some form of calculus as a senior. And you all should be taking AP stats in addition to pre-calc next year as juniors. You can leave this building easily with 9. And AP stats maybe only 3. So 4, 4, and 3. That puts us at 11. 11 college credits you should be leaving this building with. And you can throw on some computer courses if you want. But you all should in reality be leaving with 11 credits. That's the plan, and that's why we're all here. Now, this is your next unit notepad. Make sure that your name is at the top, please. We're hopefully going to burn through these a little bit quickly. This is stuff that we're working off the assumption that you know. The first thing is you have to know that every positive number has 2 square roots, one positive and one negative. Did you do the assessment here? Pick one up. Keep going. It has 2 positive square roots. That's if you are taking the square root, it's plus or minus. The positive one is called the principal square root. If you are given a square root, it's only equal to whatever that value is. So the square root of 16 would be equal to 4. Now, if I have this, if I have x squared is equal to 81, that would give me 2 answers when I take the square root. This is when you would need a plus or a minus. The other end of it is, if I take the square root and it's given as the square root of 81, that would mean that I have 1 answer and not a plus or minus situation. If it's part of an equation where you take the square root, there's 2 answers. I think we talked about this before, but the degree or highest exponent in an equation tells you the number of answers you should get. That's how you know it's going to be plus or minus. So, questions on that? Also, you cannot, as of yet, take the square root of a negative number. We will be able to later on in the unit, but it does not give you a real number. It gives you what's called an imaginary number. Yes?
It's somewhat related. So if the highest exponent is the amount of answers, if we're taking a cube root, so we have a positive, a negative, and a 1.
You'd have 3. There's a positive, a negative, and an imaginary component. You'll see when we do this out, like if you take the square, let's say the cube root of 8, technically the answer to that would have 3 answers. 1 would be 2, and then there's 2 imaginary answers back onto it that we haven't done yet. Looking at what we've got for the first one, you're going to be able to, and this is some of the work that we're going to be doing is without a calculator, but if you need it to help support yourself as we work our way through, you can go ahead and use it. What is the square root of 169 going to give you? Cece, what do you say? What number times itself is 169? You know? 13. And it's not going to be plus or minus because the square root was already there. Now, if we go over on the right-hand side, you've got x squared minus 1 equals 168. Gerard, what would you do to get an answer? So you get x squared equals how much? And then what are you going to do? Is that correct? It's going to be plus or minus because it's involved. You're taking the square root in the process of solving. That's the difference between them. Sometimes there's plus or minus, and sometimes there's just plus. Next one up, what would we do, Ben, to start off number 3? You've got 4x squared minus 49 equals 0. So I've got 4x squared equals 49. What would you do next? So I would have x squared equals 49 over 4. What's your next step? Perfect. Take the square root of both sides. For some reason, we all think that this is super difficult. If you need to go into the calculator, I guess you can. Olivia C., what would you get if you took the square root of 49 fourths? Yep. Before you go to the calculator, stop. What's the square root of 49? What's the square root of 4? What's the square root of 49 fourths? 7 over 2, yeah. Just take the square root of the numerator and the denominator. Number 4 is where it starts getting a little bit dicey, because this is something you haven't done explicitly yet. Looking at this to begin, let's see. Stephen, what would you do to start this off? So now, 50 is not a perfect square, so x would be equal to plus or minus the square root of 50. However, 50 has a perfect square factor. Hands up, please, if you can tell me what perfect square is a factor of our radicand. 25 times what? So I now list that out. X is equal to plus or minus the square root of 25 times 2. And when you take the square root of 25, that's a 5. And that becomes a coefficient in front. So it's 5 times the square root of 2. Now, you could mindlessly go into the calculator and type that in. If you need a decimal approximation, that's one way of getting it. So before we do the next group, we need to go through and start simplifying out. Before I do that, on the right-hand side, I'm going to list out what my perfect square numbers are. Now, as we do these, some of them are easy, some of them are a bit hard. I'm not concerned about taking the square root of numbers. As we do these out, our perfect squares, we should start off to begin with. 1 is a perfect square, but we don't count it. We have 4, 9, 16, 25, that's 5 squared. 36 is 6 squared. 7 squared is 49, that's 7. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. And I think that 16 squared is 256, and that continues on. You can always generate that list by simply squaring the individual numbers. Make sure you don't omit anything. I'm not concerned about that. What you have to understand is this. And the answer to this in Algebra 2 is different than the answer to it when you take calculus. We're going to be going through and giving out the answer today as though you were taking calculus, so you don't get confused. The Regents does not demand that you go through and list out the same thing. Technically, to start off, if I were to take the square root of x squared, you're asking what times itself gives you x squared. And the simple answer to that is x. But the correct answer to it is the absolute value of x. Because if you have an input and you square it, you have lost the negative sign, and then you take the square root of that newly positive value, you're going to get out only the principal root, which is positive. You're going to say, though, going forward, the square root of x squared is just x, and everyone will be okay with it until you get to calculus. Let's focus on, and by the way, this is called a square root when we say it. This is called an index right here. There's a little perch on the outside of the square root, and on that's an imaginary 2. Now, if I ask you to take the square root of x to the 4th, hands up please if you can tell me what the square root of x to the 4th is, or what times itself would give me x to the 4th. Okay? Terrific. Now, notice what you're doing. You're dividing the index into the exponent. 2 goes into 4 twice. Who can tell me what the square root of x to the 100th power is going to be? We've got 1, 2, 3 of you, 4. What would we say, Mike? No. Not x to the 10th. Yeah, because you're taking and dividing in how many times does your index go into the power. Now, let's try it differently because all of these have worked out nice and neatly so far. Can anybody see where this might, or can anybody give me sort of an example where they're going, I don't know what I do if I got this as my radicand? What do you want to say? Sure, give me one. Okay, x to the 7th. Now watch what happens. Because this doesn't work out like the other ones did. But the process is exactly the same. You just haven't been shown how to go forward. How many times does 2 go into 7? Hands up, please, if you can tell me that. And I don't want a decimal. Yep. 3 times with the remainder of what? 1. So on the outside as a coefficient, we would have x to the 3rd. We have 1 that's still stuck under the radical. So x to the 1st, or just x. 2 goes into 7 3 times with the remainder of 1. The quotient goes on the outside. As a power, the remainder gets stuck underneath. Let's take a look here. What would we say if we have x to the, let's say, 121st? Hands up, please, if you can tell me what that would break down and become when you simplify that root. I've got 2 people so far. You need to go to the calculator to help yourself. You feel free to. X to the 60th times the square root of x. And that continues over and over again. If the number is even, 2 is going to go into it. This only works, though, for square roots, but the process is the same. Take a look, please, at question number 5. Hands up, please, if you can tell me what you think 5 would simplify to. You can tell me what we would get for number 6. 2 people. Steve? Now, the next one up is going to be a little bit awkward. You're going to have to break this one down. You can't take the square root of 12, but 12 has a perfect square factor. Hands up, please, if you can tell me the biggest perfect square factor that goes into 12. 4 times what?
2.
Now, this next one may help you. X to the 9 is not a perfect square. But what perfect square is just below x to the 9? 2. X to the 8. But we need to give something equivalent, so this would be x to the 8 times x. Y to the 14th is a perfect square. So now I'm going to start off by taking some square roots. Lauren, see what's one square root that you can take that's in the radicand position right now. Okay, so square root of x to the 8th is x to the 4th. Is there more that you see? Start on your way across with the square root of the 4th. 2. And what other piece do you think you might want to be able to take the square root of? And what's that going to be? Careful. Don't take the square root of 14. How many times does 2 go into 14? With no remainder. With the variables, you're seeing how many times the index goes into the power. Notice I didn't say 2, I said the index. So this would be y to the 7th. Now to give out your final answer, you're going to have coefficients, which are in front of your radicand. So this would be 2 x to the 4th, y to the 7th, times the square root of 3x. All of those are being multiplied going across. Questions on that? Hands up, please, for 8, if you can tell me how you would want to break down 200, m to the 8th, n to the 7th. We've got one person. 2, 3. You need to find the biggest perfect square that goes in a number. Try to break down whatever variable does need to be broken down. We've got 3 of you. Logan, what do you think?
196.
No, that goes in exactly. That goes in exactly.
25.
25 does, not the biggest. Who can help us out?
100.
100. You're going to find, and you're going to, the problem is you can use 25, but then you have to simplify a second time. Okay? So we'll break this down into 100 times 2. Is the m to the 8th a perfect square? Hands up, please, if you can tell me how you want to break down n to the 7th. No? Oh, not at the end. How can I rewrite n to the 7th before taking any square roots? Yeah. This one right here, that's the n. How did you split it up so you could take the square root? How about we do n to the 6th times n? And then when you take the square roots, that's what you're going to get as an answer. So to proceed from here, I say, all right, I got this. Now I'm going to take my square root. Square root of 100 is 10. Square root of m to the 8th is m to the 4th. Square root of n to the 6th is n to the 3rd. So we go forward here. This would be 10. M to the 4th, n cubed, square root of 2n. Now, questions on that? Looking at what's there for the next grouping, we need to fill this in first. We need to fill in what our perfect cubes are going to be. If you don't have these memorized, it's okay. You can always get them from doing some simple mental math or use a calculator if you need it. 1 to the 3rd is one that's not going to help us at all. 2 to the 3rd, hands up please if you can tell us what our first perfect cube would be. 8. Who can tell me what my next perfect cube is going to be? 3 to the 3rd is not 9, it's 27. How about 4 to the 3rd? 64. Who can tell me what our next one up would be? Close. 125. So that's 6 to the 3rd is 216, 7 to the 3rd is 343, and you can generate that list anytime you need to. Now we're going to take some perfect cubes of variables. The cube root of m to the 3rd power is going to be m. How about the 3rd root of m to the 4th? Hands up, please, if you can tell me what you think that would break down to be. It's not a perfect square. You're taking a cube root, but the process is identical except for the rest. 2 people? 3? 4? Close. You said m to the 3rd square root m? No. That's close.
M to the square root of m.
Close. As you listed it out, you just told me this.
Or cube root of m.
Cube root of m. Why is this only an m and not an m to the 3rd?
Because you already cube rooted it.
Yeah. How many times does 3 go into 4?
Once.
with the remainder of
1.
1. Take the index, divide it into the power, anything that's left over gets put at the end. How about this? You can tell me what the cube root of m to the 5th would simplify down to be. One person, 2 of us, 3 of us, 4. How many is that?
M times the cubic root of m.
Yeah. M times the cube root of m squared. How about if we say the cube root of m to the 16th? Three of you? 4? We can do better than that. Cube root?
Yeah.
Okay. No, because you can do more.
M to the 5th times cube root of m.
How many times does 3 go into 16? 5, and then times the cube root of m to the 1st. Because 3 goes into 16 5 times with a remainder of 1. Let's do one more. How about if we did the cube root of m to the 91st power? We've got 1, 2, 3. We're stuck at 3. Oh, come on, we're better than this. 4. Take the jump here. 5. That's great. Really good. Now, can we go through and apply that? Some of these are going to be easier than others. I'll tell you right now, 9 should be a walk in the park. Who can tell me what 9 is going to be when we simplify it down? We got to take the cube root of 64, p to the 112. What times itself 3 times would give me that radicand? 3 people? Seriously? 4? Rebecca, what do you say?
4 through
P to what power? How many times does our index go into our exponent? How many times does 3 go into 12? 4. No remainder, so nothing in the radicand. This next one's going to be a little bit tricky, and some of you will see it. We need to take the cube root of negative 27. If the index is odd, you can have a negative radicand. You can tell me what the cube root of negative 27 is going to be. 4 of you? Negative 3 m squared n to the 6th. You can take the cube root or any odd root of a negative number. It just can't be a square root or an even root. This next one's going to be the most awkward. I think we'll do out number 12 to start. I want to break this up because 81 is not a perfect cube. It is a perfect square, but that doesn't help us at all when we're looking at perfect cubes. Who can tell me, please, what we would want to go through and do, how I would want to break down negative 81 so I can start simplifying?
We define it by the closest perfect cube, which is negative.
Which is what?
Negative.
Nope.
Oh, negative.
Oh, well, if you cube it, what's the
Negative 27.
negative 27? Yeah. So if we did this out, I'd list this out and I'd say this would be negative 3 to the 3rd, which is negative 27, times what value to get the 81? 3. Now, how do I want to break up m to the 10th? Hands up, please, if you can tell me, because that's not a perfect cube. How would I want to split that up? Spencer, what do you say? M to the 10th isn't a perfect cube, but how can I break it up so I can see the perfect cube that's there? times. Good. And n to the 12th we're actually good with. So we get to that point. Questions on that? And let's keep going. Eva B, what would you go through and take the cube root of now? What's that going to be when you take the cube root of m to the 9? Nope. How many times is, what's the cube root of that? What else can you take the cube root of? And what's the cube root of negative 27, or what times itself? What times itself 3 times gives you negative 27? Close. Negative 3. And there's one more piece that we need to take the cube root of. Do you see it? So now these all go in front. All 3 of these are now your coefficients in front. So this would be negative 3 times m to the 3rd times n to the 4th times the cube root of, and in the radicand, is it just the 3m that we're left with? Do you need to put the multiplication signs there? No. Now, questions on this? Yes. On the index, you mean? Like right here? Because you're taking... Oh, this? Because you took the cube root of negative 27. That's a number. You get that from taking negative 3 times negative 3 times negative 3. Is there anything, though, that times itself will give you, times itself 3 times, will give you a 3? No. That's why it's still left underneath there. Let's do this. Now, we're going to list out our perfect fourths. You go through and start generating out this list. Use your calculator if you need it. I could care less. I'd rather you get it right than sit there and try to be a mental math also and stare at the ceiling all day. No, just list out the perfect fourths. Don't even simplify anything yet. Just list out the perfect fourths. Looking at this, we're not going to count 1. Teresa, what's 2 to the 4th going to give you? Can you tell us how many of them do you have listed out so far? What did you get after the 16? Did you get any more? And then? Now I tell you right there, if you need more, you can keep going, but I don't think we will. Let's take a look, please, at number 14. If I asked you to simplify out number 14, I'm taking the 4th root of this. Who can tell me how I would want to break this down? We got 1 person. 2. Sam, what do you think? How would I want to break this down so that I have a perfect 4th as a factor? We'll look at the 32. What perfect 4th goes into 32? 16 times? Times 2 to get us that. Now, do you know how you want to break up the m so you can take the 4th root of it? Terrific. And we're good with the n to the 12th. Who can tell me what we would do now? We've got all of this done. What can we do from here? 1 person. We can do better. 2 of us? Oh, come on. Come on. What can I take the 4th root of that's there? Aaron, what do you say? What's the 4th root of 16 going to give you? No? What it times itself 4 times gives me that 16. 2. So let's change this over to a 2 here. What else? Felix? And what's the 4th root of that? Jordan? What else can you take the 4th root of?
The n to the 12 power would become nt.
So that leaves us with coefficients of 2m squared n cubed times the 4th root. Notice the 4 is small and on the index of 2m squared. Questions on that? Let's keep going then. The last thing that we're going to deal with today is called rationalizing. And by the way, we could do perfect fifths and all of that. The process is exactly the same. You make your list, find the factors that go in, and simplify out those variables. When we rationalize our denominator, please understand there are no radicals left in the denominator, and no denominator can have a radical. What we're going to do, and I hope that we're all in agreement, hands up please if you can tell me the only value that I can multiply something by without changing its value. What's the only value I can multiply by without changing its value? 1. Everything else, if you multiply by it, changes its value. 0 makes it automatically a 0. So we're going to have to multiply this by something that we'll call an ugly one. So 1 looks clean, looks easy, looks simple. 7 over 7 is what we would call an ugly one. And the ugly ones can get really ugly, like the cube root of 24 over the cube root of 24, or a binomial over a binomial, or a trinomial over itself. All of those will give us 1. Looking at what's there, we have to ask ourselves this. As of now, the problem is the root 5 that's in the denominator. And this is a square root, so what's the smallest perfect square that 5 multiplies into? Hands up if you can tell us that. The smallest perfect square that 5 multiplies into. We got 1, 2, 3 of us, 4. 25. What do I need to multiply the 5 by so it becomes 25? So I'm going to multiply this by root 5 over root 5. That's just an ugly one. When I go across, what's root 12 times root 5 going to give me? Well, what's 12 times 5 going to give me? Angela, what do you say? 60. So I have root 60 in the numerator over, now in the denominator, Tammy, what would you be left with in the denominator going across if you took root 5 times root 5? All of a sudden, though, we just achieved our end goal. Because in the denominator, I now only have a 5. Let's look at the numerator. And by now, we should be able to do this in our head. Who can tell me what the biggest perfect square that goes into 60 is? You can use your calculator. I don't care. I want you to be able to do it, though. You got 1, 2, 3, 4 of you? No, 5 is not a perfect square. Felix? No, it's got to go in exactly. 4 times what? What's the square? Which number was the perfect square that you gave me? 4 to the 15? 4. What's the square root of 4? So when we simplify this down, root 60 turns into 2 root 15. Final answer. No further reductions can be done. Questions on that? Let's try another one. And these get progressively more awkward. Look at the next one. I have a radical in the denominator. We need to go through and simplify that. I look at my radicand, which is 8x. Who can tell me the smallest perfect square that 8x will go into? What's the smallest perfect square that 8x will go into? We've got 1, 2, 3 of you. What's the smallest perfect square that 8x goes into? 4, 5. Deanna, what do you say? Close. 64 is a perfect square that 8 goes into, but it's not the smallest. When you get the same answer, you just need to simplify again. No, that is a potential one, it's just not the smallest. If you did it on your own, you get to the same answer, just need extra reducing. 16. What else needs to be tacked onto that?
Yeah.
The x squared, okay? What do I need to multiply this by? So my denominator is going to be a 16x squared. Hands up if you can tell me that, because that's going to help us make our ugly one. So I'm going to multiply this by root 2x over root 2x. That's not changing anything. Now, in the numerator, when you multiply radicals, you just go across. That's from Algebra 1. So, Caleb, what do you get when you multiply across in the numerator spot? Yeah, and what do you get in the denominator spot? Terrific. It would be radical 16x squared, but you can make that leap. You can take one square root at a time in your head. That's fine. Questions on that? Is the radical in the denominator gone? Absolutely. Now, for number 17, just as this is one fraction, we can actually separate it up into two. So this would be radical x over radical 2. That's not going to change anything. Who can tell me the ugly one that I would want to use in this question and why? What ugly one am I going to pick in this question and why? Got 1, 2 of us, 3? Yeah. Why? Terrific. So the ugly one that I'm going to use is root 2 over root 2, which is going to give me in the numerator. Oh, did you tell me what was going to be left in the numerator or no? What would it be? Can you reduce those 2's? I'm going to split this up. How is this question? Hands up, please, and tell me how this one's different than the ones we've done so far. Before we panic. Before we panic. How is this different than the ones you've done so far? Some of us aren't going to see it, especially if you go too quickly. Cube root. So let's go through and split this up. This would be the cube root of x squared. Can't take the square root or cube root of it. This would be the cube root of 3y. Who can tell me the ugly one that I want to use here if I'm trying to remove the radical from down below? We've got 1, 2 of us, 3, 4, 5. What do we say? McKenna, what do you think? No. No, because what you're doing, careful. She's trying to treat it as though it's a square root right now, and if it was, you'd be right.
Oh,
It's a cube root. So what's the smallest perfect cube that 3 goes into? Hands up, please, if you can tell me. The smallest perfect cube that it goes into. We got 1, 2, 3, 4. What do you want to say? 27. And we also need to get those y's gone. So what ugly one would I use if I'm trying to get a 27 in there and a y that I can go through and take the cube root of? No. You need 27 at the end, so you're not going to multiply by it. You need it to become 27. 9. Close. Now, I'll say that as of now, before we give up on it, analyze why that's not right. It's very, very close to right. But it's, again, the mentality. You guys only do perfect squares for some reason. You have to remember this is a cube root. Who can tell me why that's not going? It's very close, but it's not going to give me what I need to have happen. We've got 4 of us that can tell me. Close. What would my ugly one be? It's not 9y cubed. You're very close. Why is it going to be 9y squared? So if I have a cube there to start, I'd have 9y to the 4th. If I make this 9y squared, going across in the numerator, I'd have the third root of 9x squared y squared all over the third root of 27y cubed. Square roots don't apply. We can't simplify down any of this in the numerator. But who can tell me what the denominator is going to be? 3y.
Okay.
Yes.
Why can't you do 3y squared as the multiplying thing, because then it would just be 9y to the third.
Is 9 a perfect cube? It's a perfect square. Again, this question's different because it's a perfect cube. So there's a lot of new. If it was a perfect fourth, we'd be working with a whole new set of numbers. Let's see if we can get one more. Here we go. For the fourth. Yeah, let's do this last one here. Look back to your fourths if you need to. Who can tell me the smallest perfect fourth, because this is the fourth root, that 3x squared will go into? Go back and check your list. What's the smallest perfect fourth that 3x squared is going to go into?
81.
81. All right. What do I need to multiply by to make that happen?
27.
Close. That took care of the 3.
27x squared.
When I multiply across now, this is the fourth root of, now in the numerator we would have, what is that, 54x to the third? But what would I have down in the denominator? Well, this would be the fourth root now of 81x to the fourth. Can you take the fourth root of 81x to the fourth? What is it? So this is the fourth root of 54x cubed all over 3x. Questions on that? Now, what's that? This denominator, because what's the fourth root of 81? Not the square root, but what times itself 4 times gives me 81? 3. And then the fourth root of x to the fourth is just an x. Technically, the absolute value of x. Now, your homework tonight is to go through and complete any of the questions that we did not do. Or complete the questions, that are in your homework packet. They need to be done on separate paper. Do you have a physical copy of the homework packet? Where can you find it? Google Classroom. I'll try to message it out to you through Reminds today as well. You want a copy on your phone? All right. Guys, can you put your calculators back? And can we kill those lights on the side, please?